Welcome to qnawire.
Hi, I'm David and I'm here to help you answer your question. Now let me bring up your question here. In the question here, we are going to discuss about the hypothesis testing. We want to test the evidence to conclude that the two population variants differ. So it means that when you test the null hypothesis, then the sigma 1 square equal to the sigma 2 square versus the alternative hypothesis, then the sigma 1 square will not equal to the sigma 2 square. And in this question here, we're given the n1 equal to the 9, and we have the s1 equal to the 4.5, and n2 equal to the 16, and the s2 equal to 5.5. Now, from this information, we will be able to find the test statistics denoted by the f, and the formula will be the bigger s will be the s2 square divided by the smaller one, the s1 square, and then we get the 5.5 square divided by the 4.5 square. And if we compute this one, we have the 5.5 divided by 4.5 square, then we get equal to the 1.494. And then the next step, I will compute the p-value. The p-value equal to the probability of the f, the degree of freedom for the s2 on the top, therefore will be the n2 minus 1 will be the 15. The degree of freedom for the denominator equal to the n1 minus 1 will be 9 minus 1 will be the 8. That will be greater than the test statistic 1.494. And to compute this probability, I will use the f distribution, and with the degree of freedom equal to the 15 and the 8, and this one will be greater than the 1.494. Then we get equal to the 0.2891. And when we compare the p-value with the alpha, we see this one greater than the 0.05. Therefore, we fail to reject the null hypothesis. And when we reject the null hypothesis, we will conclude that there is not enough evidence to conclude the sigma 1 square will not equal to the sigma 2 square. Now the question asks me to use the confidence interval, and here the confidence interval for the sigma 1 square divided by the sigma 2 square, it will be the sigma 1 square over the sigma 2 square. It will be between the s1 square over the s2 square, and then we will divide by the f of the 1 minus alpha over 2, and this one will be the s1 square over the s2 square, and then times the f of the alpha over 2. Now when we have the critical value here, the f of the alpha over 2, here we have alpha equal to 0.05 divided by 2, it will equal to the 0.025. And if we compute this one, we will have this will be at the value 0. This one it will be equal to the 0.95, and then we got this one will be the 0.3787, and the f of the 1 minus alpha over 2 it will equal to f of the this is 75, and again this one will be the 0.3126, and this one will be f of the 0.975, and we get this one equal to the 4.1012. Now if we plug in into the formula, we will have the sigma 1 square over sigma 2 square will be bounded between, here we have this will be the 4.5 square over this one I have to turn the S2 over S1 to make it more precise. So we do this one will be the right order here. So this one will be the S2 over sigma 2 over sigma 1, S2 over S1, S2 over S1. So we get this one will be the 5.5 square over the 4.5, and then this one we times with the 4.1012, and here we have the 5.5 square over the vision square 4.5 square, then times in the 0.3126, and then taking the square root here. Sorry, because it will be the sales, the variance, so we don't need to turn the square root, and the final answer will be the sigma 1 square over the sigma 2 square. It will be between, here we have the answer, and then divide by the 4.1012 will equal to the 0.3642, and this one we have 5.5 square divided by 126 equal to the 4.7739, and we see that this interval here it contains the value 1, so therefore we're going to fail to return the null hypothesis, and that will be the answer for your